projects. In this video, we are going to explain about the project, which is Adversarial Spam Detector with Character Similarity Network. Introduction of the project. The increasing prevalence of social platforms globally has significantly impacted people's lifestyles. However, the widespread issue of spam messages poses a serious challenge affecting user experiences and violating both user and platform interests. This project focuses on addressing spam messages within Lizzy, one of the China's most popular audio apps, which receives billions of daily messages. The primary objective of the project is to develop an effective spam detection method termed Lizzy Adversarial Spam Detector, which is also called as LZASD. This method is designed to combat challenges in spam detection, particularly the adversarial actions taken by spammers and the scarcity of labeled data, which traditionally hinders the effectiveness of unsupervised methods. The project acknowledges the evolving tactics employed by spammers, such as using different expressions with similar meaning and deforming keywords. Traditional rule based approaches are insufficient, and even natural language processing NLP based models like Word2Vec and BERT faces limitations due to spammers constantly finding new ways to deform keywords. To overcome the challenges posed by spammers, the project introduces a novel character similarity network based on glyph and pronunciation. This network, a key component of LZASD, works in tandem with a character embedding model to learn character embeddings. The resulting sentence embedding is then fed into the classifier to determine the probability of a message being spam. Recognizing the impracticality of manually labeling billions of messages and the inefficiency of sampling messages for labeling due to the sparse occurrence of spam, the project adopts active learning. This approach efficiently trains the LZASD model, providing a solution to the lack of labeled data and enabling the detection of spam messages on Lizzy vast platform. The effectiveness of the proposed model is demonstrated through the offline experiments and online evaluations. Objective of the project. The primary objective of the project is to develop an adversarial spam detection solution specifically tailored for Lizzy, a renowned audio app in China, to address the escalating issue of spam messages affecting user experiences. The aim is to tackle the dual challenges of adversarial actions by spammers and the shortage of label data within Lizzy's spam detection system, aiming to enhance overall efficiency, and accuracy. The goal is to develop multiple models with an objective of predicting whether a given text is spam or not spam. The classes to be predicted include spam and not spam. The aim is to develop multiple models including LZASD with adversarial network, BERT with graph convolutional network, LSTM with BiGRU, LSTM with GRU, logistic regression, gradient boosting decision tree switches, GBDT and a stacking classifier, and we split the data into training and testing sets and the training model for spam classification. The goal is to use a set of evaluation metrics including accuracy, precision, recall, and FN score to assess the performance of all the models built in the project. To implement this project, we need software and hardware requirements. Coming to hardware requirements, we need application, operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. To implement this project, we have designed various steps in the flow of work. The first step is importing the packages. This step involves importing necessary libraries and packages that are required for the project. We imported pandas for data manipulation, NLTK for natural language processing, scikit-learn for machine learning algorithms, NumPy for numerical operations, matplotlib and seaborn for data visualization, keras and TensorFlow for deep learning. The next step is exploring the dataset. This step involves loading and exploring the dataset to understand its structure, focusing specifically on spam classification. Key elements such as the target variable and potential features are identified. Visualization. Visualization begins with examining sample outcomes and generating a word cloud to visually represent the most frequent words in the dataset, providing insights into the data distribution. Data processing step involves in cleaning and preparing the data for model training. Here tasks include removing the URL and other characters, removing punctuations, removing stop words, and normalizing the data, limitization and stemming. Limitization and stemming are applied to normalize text by reducing words to their base or root forms, ensuring consistency in natural language representation. This process aids in reducing dimensionality and sparsity, leading to improved model generalization and more effective information retrieval in natural language processing tasks. Coming to tokenization, here we have used counter vectorizer. Tokenization involves breaking down the text into individual words or the tokens. The project uses technique called count vectorizer to convert the text into numerical forms, numerical features suitable for machine learning models. Count vectorizer is a text processing tool technique that converts a collection of text documents into a numerical format by counting the occurrence of each word, creating a matrix of token counts used as input for machine learning models. It represents the frequency of words in a document, producing a sparse matrix for efficient storage and processing. We also used Keras tokenizer. Keras tokenizer text is tokenized specifically for the neural network models. Leveraging the Keras library, it facilitates the transformation of textual data into a format suitable for deep learning models. We also used BERT tokenizer. BERT tokenizes the input text into smaller units, typically words or subwords. Unlike traditional tokenization, BERT uses word piece tokenization, allowing it to represent subwords and capture the meaning of words more effectively. BERT converts each token into high dimensional vectors known as word embeddings. These embeddings capture the semantic meaning and the context of words, and it is more nuanced way compared to traditional embeddings. BERT utilizes multi self-attention mechanism to weigh the importance of the different words in a sentence concerning each other. This enables BERT to consider the entire context of a word by looking at all other words in the sentence bidirectionally. Feature selection. Features relevant to the model training are selected based on the processed and tokenized data, ensuring in the inclusion of key information for classification. The next step is splitting the data into train and test. The dataset is divided into training and testing sets to enable the evaluation of the model performance on unseen data. Coming to building the model, this step involves defining the architecture of the machine learning and the deep learning models that will be used for spam classification, outlining the structure and components of the model. Coming to training the model is trained using the design training data, which is designated training data, allowing it to learn patterns and relationships within the dataset to improve predictive performance. The next step is Flask framework with SQLite for sign up and sign in. Here we implement a Flask framework with SQLite which enables functionalities for user sign up and sign in, providing a structured environment for user interaction. User gives input. In this step, user input the text that they want to classify as spam or not spam, initiating the interactive component of the project. The given input is pre-processed. The user input text undergoes pre-processing, which is similar to that applied during the training, ensuring compatibility with the pre-trained model for accurate prediction. Trained model is used for prediction. The pre-trained model is employed to predict whether user input text is spam or not spam, leveraging knowledge gained during the training phase. Along with that, we applied LDA model for topic modeling. We have applied latent dirichlet allocation for topic modeling, which helps in identifying underlying themes or the topics within the user input text, offering additional insights. Last step, which is final outcome, is displayed through frontend. The project concludes by displaying the final prediction of the outcome of any identified topics through the frontend of the application, providing users with a clear and interpretable result. Now we will know what are the algorithms used in the project. The first algorithm is Lizzie Adversarial Spam Detector. It is a novel spam detection method. It addresses two major challenges faced by spam detector in the Lizzie: adversarial actions taken by spammers and lack of labeled data. The method utilizes a character similarity network to handle adversarial actions and a character embedding model to learn embeddings of all characters in the corpus. The model generates sentence embeddings for user messages, and a binary classifier predicts whether a message is spam or not spam. The next model is BERT with GCN. BERT refers to bidirectional encoder representations from transformers. It is a powerful pre-trained natural language processing model that captures contextual information in the text. GCN is a graph-based neural network that can be used to analyze relationships between elements in a graph structure. BERT with GCN is used to enhance the project's capabilities in text understanding and feature extraction. BERT's contextual embeddings capture nuanced semantic information, while GCN can potentially model relationship between words or the elements in the graph, contributing to more sophisticated text analysis and spam detection. The next algorithm is long short-term memory. Long short-term memory, which is LSTM, is a type of recurrent neural network architecture designed to overcome the vanishing gradient problem in traditional RNNs. It is particularly effective in capturing long-range dependencies, and it is widely used in natural language processing tasks. LSTM is employed for its ability to model sequential dependencies and handle contextual information in the text. In spam detection, LSTM can capture patterns and relationships in the order of words, enhancing the model's ability to recognize complex spam message structures. The next algorithm is logistic regression. It is a linear classification algorithm used for binary classification tasks. It calculates the probability of a sample belonging to a specific class and applies a threshold to make a binary decision. Logistic regression is used as a baseline or the simpler model for spam classification. While not as complex as neural networks, logistic regression is computationally efficient and provides a straightforward way to establish a baseline performance for the spam detection task. It is often used in conjunction with more sophisticated models to compare and assess overall model performance. Coming to next algorithm, which is gradient boosting decision tree, which is GBDT. It is an ensemble learning technique that combines the predictions of multiple decision trees to create a strong predictive model. It builds trees sequentially, with each tree addressing the errors of the previous ones, ultimately improving predictive accuracy. It is employed as a powerful ensemble model for spam classification. Its ability to handle complex relationships in the data can capture nonlinear patterns and mitigate overfitting, making it valuable in improving the overall predictive performance of the spam detection system. GBDT can contribute to the model's ability to generalize well on unseen data and enhance the robustness of the spam detection algorithm. As an extension, we employed stacking classifier and other ensemble models combining the predictions of multiple individual models to produce a more robust and accurate final prediction. Also, as an extension, we have used Flash framework for user testing with the user authentication. We have used accuracy, precision, recall, and F1 score, which are the performance metrics to evaluate all the classification models built in the project. So here we have performance comparison graphs for all the models built in the project. This is accuracy comparison graph where x-axis represents accuracy score for each algorithm and y-axis represents algorithm names. Accuracy is the measure of the overall correctness of the model. It calculates the ratio of correctly predicted instances to the total number of instances. This is precision score comparison graph. Here also x-axis represents precision score for each algorithm and y-axis represents algorithm names. Similarly, we will have for other two graphs also. Precision is the ratio of correctly predicted positive observations to the total predicted positives. It evaluates the accuracy of positive predictions. This is recall comparison graph. Recall is also known as sensitivity or true positive rate. Recall measures the ability of the model to capture all relevant instances. It is the ratio of correctly predicted positive observations to the total actual positives. This is F1 score comparison graph. It is the harmonic mean of precision and recall. It provides a balance between precision and recall, especially when there is an imbalance in the class distribution. To execute the project, first we need to open the code folder which contains source code files. This is the code folder of the project. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in HTML templates. These are the model files which contain the algorithm information and that will be loaded into the project code during runtime. This is the notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. This is the dataset which we use for training the algorithms. And this is the topic modeling Python file. This is the sign-up file. This file is the database file used to store the user information. Now we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and then click on enter. By doing this, current directory will change to the code folder's path. So here we can see that current directory is changed to the code folder's path. Here we need to type the command python space app.py to compile app.py file and then click on enter. This will execute Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which will be the local host and the port unless configured differently. This is the local host and this 5000 is the port. Now we need to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Here we need to paste the link and then click on enter. This is the web page of the project, which is displayed in the browser, and this web page is built by using the Flask framework. Here we can see a sign up link. First, we need to sign up, so click on it. Here we need to enter all sign up details if you are signing up newly. I have already signed up and have an account in it, so we will directly sign in. For that, click on sign in now. Here we need to provide our username and the password to log in. So I'm giving my username and the password. Now we need to click on login. We have logged in successfully and we are redirected to prediction page. Here we can see a text box wherein we need to give the input message. Based on the given input message, we will get the prediction that the message belongs to spam or not spam. So here I'm entering the message. Now click on predict. Here we got the prediction as the text type is ham SMS, which means that it is not spam SMS. This particular message has been classified as not spam, and the topic for the paragraph is most dependent upon these words. Now we will try giving the other message, so click on home. I have entered the message here. Now click on predict. Here we got the prediction as the text type is spam SMS, which means that this particular message belongs to spam. And the topic for the paragraph is most dependent upon these words. Now we will give the other message. Click on home. I have entered the message here. Click on predict. Here we got the prediction as the text type is spam SMS and the topic for the paragraph is most dependent upon these words. Now we will try giving the other message. Click on home. I have entered the message here. Click on predict. Here we got the prediction as the text type is ham SMS, which means that it is not spam and the topic for the paragraph is most dependent upon these words. Now click on sign out. In this way, if we give the messages to the system and then the system will detect whether the message is spam or not spam. Conclusion of the project. The project successfully introduces a novel spam detection framework called LZASD, specifically tailored for LZI, utilizing character similarity network to proactively address adversarial actions by spammers. This innovative approach contributes to the effectiveness of spam detection on the audio platform. The project leverages diverse ensemble of models including BERT GCN, LSTM, logistic regression, and GBDT, providing a comprehensive solution for spam classification. This diverse set of models enhances the ability to capture various aspects of spam messages and improves overall model robustness. Integration of the Flask framework with SQLite for user sign-up and sign-in adds a user-friendly interface to the project. This facilitates user input for testing, providing a practical and interactive platform for users to assess the spam detection capabilities. The primary beneficiaries of the project are Lizzy platform users who experience an improved and spam-free audio environment, contributing to enhanced user satisfaction. Additionally, Lizzy as a platform benefits from strengthened integrity and administrative efficiency in managing moderating content.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.